Hi, my name is Mike Flasco. I'm a Senior Program Manager lead on the Big Data team here at Microsoft. And today I'm going to show you a little bit about how to use Hadoop running on Windows Azure to process large volumes of structured and unstructured data. Alright, today we're going to look at a couple of ways to process large volumes of structured and unstructured data using Hadoop on Azure. What I've gone ahead and done already is log into the Hadoop on Azure console. Once you log into the Hadoop on Azure console, you come to kind of a home screen like this. We'll take a brief tour and then look at how we go about interacting with some data. The first thing is I've got a pane to submit a new job. If I go down, I've got a few options to work with my Hadoop cluster that's running now on Azure. The first is often I want to first identify what is the data that I want to process using my Hadoop cluster. And so if I go into Manage Cluster, I've got a few options. I can interact with data from the data market or pull data from Azure Blob Store or Amazon S3. In my particular case, I'm going to use for our first demo some sample data that we've preloaded into our cluster, which is an ebook. So going back over to my home page, I look in, I've got a few more options, but what I want to do is I want to process an ebook using my Hadoop cluster and count the number of words in the book and figure out what is the most used word in the book. So obviously an ebook is a fairly large amount of just completely unstructured data. And so what we're going to do is we're going to use a component of the Hadoop ecosystem called Pig to write a script that will kind of partition up our ebook, fan it out across our nodes, do the count job in parallel across pieces of the book, and then tell us what the most commonly used word is in that ebook. So let's get started. What I've done is I've jumped into the interactive JavaScript console. This is basically a console that lets me interact with my Hadoop cluster over the web. So the first thing I'm going to do is do a quick ls to see that I have kind of an empty directory here to work with. And what we want to do is first get our MapReduce program that we're going to use to do the word count on our behalf. And so let me upload my my MapReduce program. So I'm going to say put. I can browse to my program called word count. I'll open that up and upload it into my cluster. Now if I do ls, we can see I have word count sitting there. And if I take a look at word count, you can see that we've got a JavaScript file that has two functions in it. The first is a map function, the second being a reduce function, which is the core programming model when you're working with Hadoop clusters. The map function is going to count words in partitions of the ebook, and the reduce function is going to aggregate those counts. So the next thing I need to do is basically tell my cluster to run this MapReduce program against that ebook. Just to give you a sense of what the ebook looks like, it's one of the Project Gutenberg books, and we're going to process the entirety of the book, finding the most used words. So DaVinci.txt I've preloaded up, or actually we've preloaded up into Hadoop on Azure's example data directory, so that if you want to run this same example, it's already there for you. And so now what I need to do is execute my MapReduce program against that sample data. So here, what we'll do is use an API we have that wraps a lot of the common pig commands, which are an easy way to process data in Hadoop. So let's start by going pig.from, and here we're going to identify the example data directory that has that ebook preloaded for us. Next, I'm going to say run the word count MapReduce program that we just looked at. And because this is all unstructured data, what we're going to do is give the system a hint and say, actually, what's going to come out of this MapReduce program is some data, and take that and infer this schema from it. And the schema we want to kind of apply is that the first column is called word, and the second column of data that's going to come out is count. Treat that as a long. What we'd like to then do is order our results by count, descending, so that we get the most used word first. Finally, we'd like to take just the top 10 of them, and at the end, output all of this result into a directory that we'll call output. So when I hit enter here, this is actually going to kick off the MapReduce job. It's going to go and put that JavaScript MapReduce program onto each of the nodes of my cluster and go and chunk over the books. All right, so that our MapReduce job took a couple of minutes. Now it looks like it's done. And let's look at the results. So ls again, we can see there's now an output directory that's been created for us. And so now let's start to work with the output directory. So we'll say file equals fs.read. Let's read the directory. And we can see that what we've put in there is the output of our word count result, first column being the word, second being the count. We can see, not surprisingly, the most used word is the, just over 22,000 times. We can take it a little bit further, and we can now work with this data because we've taken all that unstructured data and structured it into these two columns. So now let's say data equals parse, file.data, and again, kind of laying this schema over top of the data that we have. We're saying the first column is word, the second one is count. And parse the data. Oh, sorry. We don't want to put that one in quotes. We're addressing a variable. Let's try that again. There we go. Now we've got the data parsed. And we can see we've parsed it up into just a set of JSON objects. So now we've gone from that unstructured data into some structure and into JSON objects. And so now anything that works well with JSON objects, we can point at this data. So we've wired up a couple of visualization libraries that are out there. So if I go say graph.bar data, I can kind of quickly visualize the data. Can kind of take it in different views. We can see again that the word the is kind of the dominant word in the book. And so that gives you a quick overview of how easily you can get up and going with a Hadoop cluster on Azure and start to play with unstructured data and kind of quickly get to some interesting visualizations on top of that data, all kind of while writing your MapReduce jobs in JavaScript. All right, now let's look at a second way that we can process a large amount of unstructured or semi-structured data in Azure. So I'm going to now leave this interactive JavaScript console, and we're going to use a different technology in the Hadoop ecosystem, this time called Hive. What Hive lets you do is put a table abstraction on top of a bunch of your data, and then instead of writing MapReduce jobs, you get to write queries against that data in a high-level language called HQL. So for that, let's again jump into our interactive console, but this time go to the Hive part of it. And what we're going to do is we're going to query over some sample output from a log4j output. So imagine we were using the logging tool log4j, and it had outputted a bunch of logs, and we want to process those logs. So in our case, our input data is this time going to look like sample log output from log4j. We can see that in some rows there's a decent structure to it, and as we go down, we'll start to see that we have some different rows of different type of structure. And as we kind of scroll our way down and search for exception, you can see every now and again there's parts of the data that really are unstructured or semi-structured or has different structure than before. And so what we're going to do is just load all of this in into our Hive table and then write a high-level query to query over top of this. So we've got this file that's got different types of semi-structured data. So for that, what I've done is I've taken this sample log file, and this time, instead of working with the data that was preloaded in the example directory, what I've gone ahead and done is uploaded this into a container in Azure Blob Store, and here's the file logsample.txt. So it's already uploaded into just an Azure Blob Store container, and what I've done is I've gone ahead and hooked up my cluster to that Azure Blob Store container, which I'll show how to do in just a second. So with that, what we want to do is we've got a text file sitting off in Azure Blob Store, and what we want to do is basically tell Hive how to infer a table schema on top of that text file. And the way that we do that is we define a table. And here what we're going to do is we're going to run create external table. We're going to just define a schema and say, look, there's 7 columns in our table, just T1 through 7. We're going to just comment it. We're going to say that each column, for the most part, is separated by a space. It's stored in a text file. And oh, by the way, all this data resides in Azure Blob Store. This is our URL to represent Azure Blob Store in this container. So we're creating, basically inferring a table schema on top of a text file, or a series of text files if we wanted, located in Azure Blob Store. So what I've done is I've gone ahead and run this command in this Hive console. just a second ago. And to show you that, I'm going to say describe logs, which is the table that prior command creates, and I'll run this. And what this will do is just echo back to me the definition of the table that I had prior created. So there we go. It shows me that I've got a table with 7 columns, all of type string. And now what we can do is we can actually issue queries against that table without worrying about the fact that there's unstructured data. It's often blob store, but I get to issue queries using a high-level language. So let me go and grab a definition of a query. The first one is going to go and query the data, and it's going to say treat the 4th column as the severity column, and then count all of those, and only grab the ones that have this pattern in it, and this pattern represents the kind of verbosity we're after. So if we look back at our data again, what we're trying to do is figure out how often info messages are presented versus debug messages versus trace messages, etc. Through this high-level query. So let's take this and run this HQL query against our table. And I'll click Go. And so right now it's going to go break this query down into a set of MapReduce jobs under the covers, in this case one job, and it's going to run that over top of the text file that's actually sitting in Azure Blob Store. But all of this is transparent to me through this high-level query. Great. So the query's gone ahead and run, and now I've got kind of an output of the how often the debug message came up versus the error message versus the fatal message. And I can write a set of other queries to also take into account some of those semi-structured lines as well. So looking at a more detailed query, we can go down and see that we've got a more detailed query that can kind of take into account all the structure and semi-structure in the data. And then so lastly, what I'd like to do is show you a little bit about Excel integration and how, if you'd like, you can run these same queries outside of this interactive Hive pane and actually do it straight from Excel against your Hadoop cluster. So if I pull up Excel now, and what I've done is I've gone ahead and installed this Hive pane add-in, which is available for download from HadoopOnAzure.com, and I've connected up to my Azure cluster simply by going into cluster details and saying the description was Azure. The host in my case is hadoopdemo.cloudapp.net. This is the name of the cluster I gave it when I signed up. I provide a username and password for my cluster. In my case, Hadoop Demo. And I go ahead and connect. And what I've done is I filled in all this data beforehand, so I'm currently connected to my Azure cluster. And it starts to give me a little bit of help in terms of viewing the tables that I've already created in Hive, just in this case the logs table that we created. Once I select that, it gives me kind of a little bit of help building a Hive query. Or I can go right down to the bottom and specify the Hive query I want to run. I click Execute Query, and then the results will, after the MapReduce jobs, come back into Excel. So let me click Execute Query. And right now what's happening is it's pushing the query up to my Hadoop cluster running on Azure. And once it's executed the query, the results will be fed back into my Excel spreadsheet. Alright, so after the query runs, we get our table populated with the similar results to what we had from the interactive console. So it just shows you a quick way to work with data from directly inside of Excel. It also gives you a quick console to kind of iterate on your Hive queries. So this was a second way to work with unstructured data with Hadoop on Azure using the Hive project from the Hadoop community. Last thing I'd like to show you is rolling back up outside of the interactive console into our main page and going down. I mentioned that I would show you how to hook up this data to Azure Blob Store, because up through this point I've been saying, oh, I had pre-configured it. So again, going into Manage Cluster, you click Set up ASV. Once you've done that, it's just going to ask you for some basic connection information to your Azure Blob Store account, which you get off of your Azure portal page. You save it in there. Once you've done that, you have URL addressability to all the containers in your Azure Blob account, the same way I did with the ASV prefix. So that concludes our demo for today and shows you a couple quick ways to get up and running with Hadoop clusters on Azure. Thank you.